Every now and then I'll pause it because I'm going to show you something that's copyrighted, so I can't record it. But then I forget to go and unpause it. And I'll say, make sure I unpause this thing, and it forgets. I'm not responsible. Of course not. Okay, here's what I want from you. Well, let me see. Yeah, same time. I'm just going to put up these. And we'll see how we go. I'm going to put up the first 7. So number 1, you should have got 44. On number 2, it's a 36. Number 3, you end up with 16. On number 4, you end up with 16. On number 5, you get a 17. On number 6, we get 12 over 35. And on number 7, you should end up with negative 9 over 25. And when you end up with a negative fraction, you could have negative 9 over 25. You could have negative 9 over 25. Or you could have 9 over negative 25. It doesn't matter where the negative is. One negative in a fraction is a negative fraction. It's best to either put it in front or in the numerator. Leaving it in the denominator is going to be a little confusing. But it's the same answer. Out of any of the first 7, is there anything you want to see? Which one? This one? Yeah. I always go like when somebody says, I want to see one of the fractions, I always ask specifically which one, because as soon as I start doing one, it's always, no, not that one. It's always that, because I can never guess it. So on number 7, 6 over 10 divided by 5 over 3. There's no such thing as division. When you have division, or again, I'm always gonna reach back and see if anybody knows something that I know. Has anybody ever heard of the band Devo? From the late 70s, 80s. What happens when programming and computer nerd engineers have too much time on their hands and they like music? They form a band called Devo. De-evolution was basically Devo short for that. They have a song called With It. When division comes along, you must flip it. Because division is multiplying by the reciprocal. We don't divide fractions. We multiply by the reciprocal. Technically, we don't divide numbers. We multiply by the reciprocal. Every time we have division, it's a multiplication problem. It's multiplying by a reciprocal. That's why we just go from left to right. Every time we have subtraction, we don't subtract, we actually add the opposite. We add a negative. It's actually an addition problem. That's where you just go from left to right. So this is 6 over 10 multiplied by the reciprocal 3 over 5. Now, the rule for multiplication, when you have fractions, A over B times C over D, you multiply straight across, you get A times C over B times D. You multiply the numerators, you multiply the denominators, so we get 6 times 3, which is going to be 18. And we get 10 times 5, which is going to give us 50. But every quiz and test in the direction. And before every test, I'm going to keep telling you and reminding you, make sure you simplify the lowest term. You have to reduce. Common factor, we want to reduce it by its common factor. Factoring means breaking it down into smaller numbers. The biggest number that goes into 18 and 50 is a 2. 2 times 9, 2 times 25, 2 divided by 2 is 1, so we're left with 9 over 25. There's a quicker way, but that's basically what's happening. Yes. I have no idea. Oh, because when I wrote it on the paper, I had a negative. That's why. And when I wrote it up on the board, I didn't put a negative. That's why. I didn't copy the correctly. And well, you know what? I meant to do that because I wanted to give you an example. If you don't copy the problem down correctly, that is part of the problem. Because you don't do a problem that you want to do, you got to do the problem that you're being asked to do. Yeah. No, yeah. Here's what you also can do. Right before you multiply, even over here, hey, I could have reduced the 6 over 10 before I actually multiplied. 2 goes into 6, okay? 2 goes into 6 3 times, 2 goes into 10 5 times, 3 times 3 is 9, 5 times 5 is 25. If you reduce before you multiply, you have smaller numbers that you're multiplying. Instead of making bigger numbers, then you now have to figure out what the common factor is. You can only reduce common factors, things that multiply and equal that number, multiplication. Anything else in the first step?
Can we do number 1?
Number 1. So add, there's no parentheses, no exponents, there's no multiplication or division. Add or subtract from left to right. So why did I do that? Did I write it down wrong too? I did write it down wrong. It's supposed to be a 12. I should have had those 3 5-hour energy drinks. Maybe you're in the middle of the day, around hour number 8, I'll be settling down. So that is 60 minus 8, which is 50. I'm going to stop the recording. I'm going to have to destroy that recording. It's going to be 52. I really meant, I meant it to, okay, so let me go back. I really meant it to be a 12 because I wanted to compare number 1 and 2 if they're both 12. I did. Oh boy. So 40 plus 12 is 52. 52 minus 8 is 44. Okay. But if you do order of operations the way you might have learned it, which you have always thought it to be, if you stick in the word that's not there, the then, add, then subtract. You see addition, you might think this is 40 minus 20. That 8 to 12. it's a negative 12. So you just go from left to right. This is 40, take away 12. That gives you 28. 28 plus 8 is your 36. One of the long lost arts, or more importantly, one of the lost in translation thanks to technology, is balancing a checkbook. When you would get a check, you would deposit it, and you would have to put it in your checkbook that we just added some money to the account. And then you write a check, then you take away that money. Add, subtract, which is order of operation. And you just do it from top to bottom. Add something, subtract something, and then add, whatever. And you just did it as you went along. And it made sense. It's the same thing up here. If you have $100 and then you subtract $10 and you subtract $12, but then you deposit $50, you're not going to say, oh yeah, I'm going to add these two together. No, you spent that money. You don't get to add that and say you deposited, $62. You spent that money. Okay? Because sometimes people don't balance their, or they didn't balance their checkbook right away. They waited until the end of the week, the end of the month, maybe sometimes. People in my family waited until the end of the year. Then it really went in. Okay. Any other time it's for 7 that I messed up? Call me out. Instead, we're good over here. No, it would get better. Number 8. Number 8 is 3. Number 9 is 36. Number 10 is 6/7. Number 11 is 22. Number 12 is 29. No, 29. 296. Number 13 is 25. Number 14 is 17, x to the second, plus 24x, and minus 5. And then number 15 is 5x minus 2. Any questions on that set? Number 9. So another division. First thing I'm going to do is a positive times a positive, going to be a positive. Positive times a negative, negative times a positive, going to be a negative. Same thing with division. A negative divided by a negative, or a positive divided by positive is going to be a positive. Positive divided by a negative, or a negative divided by a positive, going to be a negative. Bottom line, if you multiply or divide, if the signs are the same, it's a positive. If the signs are different, it's going to be a negative. So all I'm looking at is it's a negative divided by a negative, the answer is positive. Now I don't have to worry about the signs. My answer is going to be a positive. Okay? So then, because it's division, when we multiply by the reciprocal, And that's why when I rewrite this, I'm not going to use the signs. I already know it's going to be a positive. It's going to be 30 over 13 times 78 over 5. The last thing I want to do is multiply 30 times 78. Maybe there's some common factors I can reduce to make it nicer before I multiply. So I'm looking at 30 and 5. 5 goes into it because it ends in a 0. But I really think one of the most frustrating things, at least when I'm grading, is when I have to take away points because you don't reduce fractions, even though I keep saying it over. Or you don't reduce fractions in the correct way. What you need to do is show that work and show what you're actually reducing. Not just go and cross things out. Because if I just started crossing things out, then you're going to wonder, what did you just do? What happened? This 30 is 5. Not enough art. That's why you follow your shots. This is 5 times 6 over 13 times, you have the 78, and I'll come back to that in a second, over a 5. So you can see 5 over 5 is going to reduce. But I know 13 times 13, or the 13s were not on the times tables. Doesn't mean you can't know something past the times table, or at least give it a shot. Does 13 go into 78? 13 is 6 times, or 78 is 6 times 13. This 78 is 6 times 13. Right. So we actually have common factors that we can reduce before multiplication happens. 5 over 5 is going to reduce, so now that's a 1. That's a 1. 13 goes into 13 one time, that reduces. So you're left with 1 times 6 times 6 times 1, so 6 times 6 over 1 times 1. 6 times 6 is 36 over 1. Which you just go straight to, that's just 36. That's what if you struggle with fractions, that's what you need to be doing right now. If you struggle with it, you need to just break it down and see what you're actually reducing. Don't shortcut it. I won't shortcut it. I don't shortcut it because I want you to be able to look at what I just what just happened and not have to guess what just happened. But I don't mind if you do this and you're up here going, oh yeah, that 5 goes into that 6 times, 13 goes into that 6 times, 6, that's a 36. You can't just go here and here and go, hey, that's 36. You got to show the work where you at least multiply by the reciprocal. There's stuff that you do have to do. Okay. Any others in this set? Well, all right, lots of stuff happening here in 12. That means I'm gonna rewrite it so I have a little bit more room to work. And all of my analogies, in terms of doing this step by step, tend to be analog and ancient. I know you're living in a digital world and it's going to be, you want it now. You're Jim. I want it now. How come it's not one step? Because it isn't. If you're actually going to do it and understand it, you got to take the time to actually break it down one piece at a time. And when I say analog, has anybody ever typed on a typewriter where you have to hit the carriage return and you put the paper in and you roll it through? This is how you do a problem. Well, 360 minus 2 to the 4 times 24 divided by 4 times 3 minus 3 times 2. First of all, you work the problem from left to right and you bring the, everything underneath it from top to bottom. You're going to work the problem from left to right and then right underneath from top to bottom. You're not going to do a little bit over here, a little bit over there, and then somehow try to put it back together when you're done. Because you're not going to put it back together in the right place. You're going to think there was a negative somewhere. You're going to think that you're supposed to multiply what you just did over there somewhere. It happens. How do I know? Because I've been doing this for over 30 years. Same thing going on every single semester. Seeing it happen over and over again. The habits that need to get fixed. The definition of insanity. Does anybody know? Doing the same thing over and over and over again, but expecting something different to happen. But you're always getting the same result, but expecting something different to happen. You know who come up with that?
Great.
Albert Einstein. If what you're doing isn't working, you need to try something else. You need a new strategy. I heard a different version of that when I was coaching basketball. Coach said, "You ever have a fly in the car? The fly wants out, and he's banging his head into the window. That fly needs a new strategy. Because that fly's not going to get out of the window no matter how much it bangs its head into the window. It needs a new strategy." So actually, the fly's kind of smart. Because what does it start to do? Annoy you until you roll down the window. Maybe that's not what the fly's thinking. Maybe the fly's just attracted to you. But the result's the same. You need a new strategy. If what you're doing isn't working, you got to change. Left to right, bring it down top to bottom. If you're going to keep going, if you're going to keep building on that, you got to fix what's not working. So from left to right, subtraction's going to happen left. So you just keep bringing that 360, bringing it down. And what I notice is you start working on all this, you forget there was a 360 up here. When I say you, I mean the people I've taught in the past, not you, everybody in my past. And then we have an exponent. 2 to the 4th is 16 times 24 divided by, in the parentheses, it's certainly okay to do this. 4 times 3, you're going to subtract that last. 4 times 3 is, you got a 12, and then a minus, 3 times 2 is a 6, and then 12 minus 6 is a 6. So you know how, well, again, you haven't used a typewriter, most of you, but you would double space. So you can write in between a couple of lines and take care of a simple calculation. Inside the parentheses, 4 times 3 minus 3 times 2 is a 6. So now this ends up being 24 divided by 6. But as we go from left to right, subtraction is going to be last. We have multiplication, division. So we multiply, divide in order from left to right. So it's 360 minus, you multiply 16 times 24, so that's 8, and then times another 4, so that's going to be 324. No? 384, thank you. And we're going to divide by 6. And that's 360 minus 384 divided by 6 is 64. 364 minus 64 is 296. What if you didn't have a calculator? Because how many of you did the multiplication 16 times 24 by with a calculator? $360 minus 16 times 24 divided by 6. Here's where fractions are your friend. Fractions, F word, friend, F word. They're pals. 360 minus, when we divide, we're multiplying by the reciprocal. 16 times 24 times 1 over 6. So what we technically have is 16 times 24 over a 6. Division is fractions. Or a fraction is a division problem. And so instead of trying to multiply this together, then divide by 6, 6 goes into 24 4 times. So this is 360 minus 16 times 4 is 64. It's easier to multiply 16 times 4 than 16 times 24. How are you supposed to know to do that? You just saw an example. And that's something you start thinking about doing. Anything else on that side? 14. $15x squared plus 13x plus 1. And then we have addition plus 2x squared plus 11x minus 6. So simplifying, combining like terms, terms that are like each other, similar terms. When you have like terms, the variable parts have to be exactly the same. So if there's variables involved, they have to be exactly the same variable letter, and they have to have exactly the same kind of power. So in here, 15x squared plus 13x cannot be combined together, because if I go 13x squared plus 13x, do I have x squareds? Do I have x to the first? They're not the same kind of variable, so I can't add them together. No, you don't go x to the third, because you only change the power if you multiply x times x squared. So you're not going to do x. I mean, if you have If you have 3 plus 3, you get 2 times 3. 2 threes added together. You do not get 3 to the second, because that means multiplication. If I have 3 squared plus 3 to the 5th, I cannot add those together like I did here. They're not the same power of 3s. I do not get 3 to the 7th. This is 9. This is 243. So when we add those together, we get 252. Okay, 3 to the 7th is going to be like 18 something. Not the same answer. So, got to know rules of exponents. Like terms, the variable and the powers have to be the same. So, there's nothing you can do here. You drop the parentheses. Once you've done everything you can do, you can drop the parentheses. And then we're going to add this to it. In here, there's no like term. So, plus this one. So, we add 2x squared. Plus a positive 11x, we're going to add the 11x, and then plus a negative 6, we're going to subtract 6. When you add, the signs are going to stay the same, unlike number 50. I know some of you do something different. I don't see it working out real well. You start doing like, I'm going to write this underneath over here. It messes up when you're trying to solve an equation. I see it happen all the time. It's a shopping list. You want to combine all the like terms together. When you go down the aisle, you have a shopping list. You're going down the market. You go into the market, and you're checking off on your shopping list everything you're putting in the basket. I want to gather up all the x squareds. I have 15 x squareds, and there's 2 more x squareds. So 15 of these x squared plus 2 more x squared. That's a total of 17 x squareds. 15 of them and 2 of them is a total of 17 of them. And if you say it like that in your head, I got 15 and plus 2 more, and 15 and 2 of them, that makes 17 of those x squareds. And then so what else we have? I want to gather up a whole bunch of x's. So I have 13 x's and then 11 x's. So 13 x's and 11 x's, that is a total of 24 x's. Or if you're Scott Pilgrim, you got to defeat the 7 evil x's. Let's watch that this weekend again. Saw that when it premiered at Comic-Con back in 2011. The cast was there. My daughter was there, and she yelled out to the stage, oh my gosh, what is the lead actor's name? Michael Cera, have my babies. And then a positive 1 and a negative 6. So a 1 and a minus 6 is a negative 5. Combine your like terms. And I'm just checking them off as I gather them together. I can't go any further because there's no like terms. And remember, that clock's about a minute fast, so let me finish this last one, number 15. And I knew I wasn't going to get to those, and that's what we're going to start 10 o'clock with. They aren't going to get off the book. And I'm going to renumber it 1 through 7. No like terms, so I can drop the parentheses. There's no like terms, but I'm subtracting instead of adding. When you subtract, it's like having a negative 1 times that parenthesis. So you distribute. I'm going to subtract a positive 3x. So it's now minus 3x. I'm going to subtract a negative 10. A negative times a negative, that's now going to be a positive 10. When you subtract the parentheses, the signs in the parentheses are now opposite. They're going to change. Every time when you subtract the parentheses and you distribute the negative, the signs are going to change. If it's addition, the signs stay the same. The signs will stay the same. But when you subtract, the signs are now going to be opposite. That's what a negative really means. It's the opposite of the positive sign. If you have an opposite of a negative, it's a positive. The opposite of a positive is now a negative. Now we combine our like terms. We have 8 x's and negative 3 x's, so 8 of them take away 3 is 5 x's. And we have 12 negatives minus 12, and 10 positives, so negative 12 and a positive 10 is a negative 2. Little tiny details. The more you force yourself to show those steps, you'll see more success with it. If you truly want to get something out of this class, if you don't want this to be a waste of time, fix your old habits. Right now, from now, don't go back. It's gonna be hard for some of you. I understand it. I get it. But if you really want to take it seriously, fix your old habits. Don't go back. This is your opportunity. I'll work with you. But you gotta commit. It's a discipline. You're able to do that. Everybody is able to do that. But you also have to ask questions. You have to engage. You guys did a real good job of it. So make sure that you do. Thank you for fixing me. I'll try to cut it down to 2 hours. I should own stock in that company. All right. Come on back to 10.
Thank you.